I see some people saying all good. So I'll keep an eye out if there's any issues, but welcome everyone to lecture 3 for our industrialized construction class. I just wanted to briefly let you know the reason we're doing this online. I mean, of course, we have the coronavirus concerns. My youngest son is actually sick with a fever, and we think it's probably nothing, but just in case, I stayed home and also wanted to make sure that, you know, just in case somehow he spread something to me, that I don't pass it to other people. So in all normal situations, I would be doing the regular lecture today, but just thought, given the situation with coronavirus, we should be extra careful. And in addition, our goal is that we'll try to record many of the future lectures for the class, so that if you also don't feel well, you don't feel that you need to come to class, but that you can still see the recorded lectures. So that's the goal moving forward. I have, by default, you should be joining the webinar on mute. And I think it'll be easiest if we just keep everyone on mute except for myself. And if you have specific questions, you can type into the chat. And if it needs further explanation, we can then unmute and have you ask kind of a longer question. But I think it will make sense if everyone stays on mute. Otherwise, it will be a bit crazy. Furthermore, this lecture is being recorded, so we'll post it after the class so you can see it. All right, so with that, I'm going to begin. I think I see I have about 20 people joining us, so that's about most people in the class. And let's start with our 2-part lecture today about understanding existing construction industry structure. And then after the break, we'll talk about disruption from Silicon Valley, including 3 case study companies: Digital Building Components, Project Frog, and Katerra. And this was a slight change, so this will be the lecture this week, and next week we will have a lecture from News Story, the nonprofit News Story, talking about 3D printed communities. I was wrong; I got the dates a little bit mixed up. So this is our approach today. All right, so let's begin. We've mentioned a little bit about the DFAB house and the robotic fabrication lab, which is next door to the Hill building in HIB. And I actually have many industry people who come and do tours of these of the robotic fabrication lab and look at some of the new on-site robotics, such as this in situ fabricator for the DFAB house. And when people come, I always ask a couple questions. The first question I ask is, what do you think? And people say that it's pretty, interesting: robotics, industrialization, construction. And then the second thing is that I always ask, well, what would it take for you to put this into your own construction company? And the response is almost always the same: is that we're a long way away. Or they kind of laugh and say, no, we'll never be able to put this into our own construction company. And I find that's really strange because, right, this is just construction. It's automated construction. It's done really well. The goal would be that it would be implemented. And I think as I thought about that more, I thought this is probably a good way to think about the current business strategy in construction. And I'll read this quote to you. So, in the construction industry, many firms have shielded themselves from technological competition. They have enjoyed a false sense of security. The industry suffers from a declining productivity, profitability, and worsening competitive position. Cost minimization rather than new product development is the dominant business strategy. And now it seems like that would be very relevant for us today, but that quote actually comes from 30 years ago. And the point here is that in construction, as we know it today, the primary goal by most of the companies is to reduce the cost. But there's a problem with that: is that you can look for inefficiencies and reduce cost, but at a certain point, you can't reduce the cost any longer. And instead, you have to think about how will you create more value? How will you make new value creation through new product development? But that seems to be something that we almost never do in the construction industry. And what I've seen is that in industrialized construction, and part of why I'm asking you to have your own new company with new product development is that there's a lot of opportunity for new product development, but we don't see it happening right now. Instead, we see most construction companies and architecture firms, I might add, focusing a lot on cost minimization and not necessarily developing new product lines. I'll say more about that as we continue on. Let me give an example here. This is an innovation journey for a company called Connextech. As you can see here, this is a new type of structural framing system, or structural steel, for those of you that are structural engineers. It's a company I started watching about 6 or 7 years ago in Silicon Valley, and they had come up with a new proprietary system. You can kind of see here, instead of a field welded joint where you would have somebody that would weld the joint into place, which actually is quite dangerous and takes a lot of time, and it's also not that sustainable. They created a new kind of a connection joint, and kind of more industrialized connection point, where you can just bolt the connections together but still have the same moment frame capacity of the steel structure. And this is a really good solution. It's actually faster, cheaper, or faster, better, stronger. It's kind of got everything going for it, except for one problem, is that it's not cheaper. It's a little bit more expensive from the perspective of the steel cost. Now, it is actually cheaper if you think about the time savings and the overall systems cost. It's a cheaper option because you can complete the building faster. But from the perspective of the tender, the steel cost is more. And so as a result, Connextech has never really kind of achieved the market growth that it could achieve based on the value proposition. And I tried to understand, what is going on? Why is it so hard for Connextech to be, to innovate in this space? And actually, when I toured their factory, this was again 6 or 7 years ago, they're also thinking about the same questions. And this was actually from a poster I saw on the wall. They had created something that they called it the beehive or the swarm. And they had a drawing about how many different actors and stakeholders in the construction industry that they had to convince in order for someone to adopt their product, right? So they had to convince all those actors on the right side: the specialty contractor, the general contractor, the construction manager, the regulations, the consultants, the engineers, the architect, and the owner. They had to convince all of those people on every single project that their space frame system was one that they should be adopted. Now, they had got it into the code book. It was accepted from an engineering standpoint, but many of the other players did not know what to do with this new system. Connextech's not alone in this problem. We have a big problem with industry fragmentation. And in fact, we see that innovations that cross over the supply chain and make kind of different stakeholders have to work together in new ways are actually much more difficult to diffuse in the construction industry. And that's because our industry suffers from extreme fragmentation. And I like to show this diagram. I think it demonstrates it quite well. We have 3 degrees of fragmentation. We have vertical fragmentation, where there's a different set of actors that are required to, let's see if I can just get my little mouse here, see if you can see the mouse. I hope it's coming through. Maybe spotlight. No, that's not gonna work. All right, well, maybe you can see my mouse. You have a different set of actors who are designing, constructing, and operating the facility. So thanks, Alina, for letting me know that you can see it. Great. So you'll have an architect, engineer design it, but then a different company builds it and a different company operates the building in the end. Okay, but then we also have horizontal fragmentation. So we have different companies within each of these different slices. So in the construction, you'll have a mechanical company, an electrical company, a structural steel company, and those are also fragmentations that exist. So now you have 2 degrees of fragmentation, vertical and horizontal. And then the 3rd degree is this longitudinal fragmentation. So in the construction industry, we organize around projects. Everyone comes together to complete a specific project. And you can see over here, here's project number 1, and that's already fragmented. But then when the project is done, everyone finishes the work, breaks apart, and now begins a new project. And most often you don't work with anybody twice. You have a whole new team that starts over. So now you have 3 dimensions of fragmentation, and this makes innovation very difficult, especially when the innovation requires that people work together in a different way. When you get away from this kind of craft administration that we talked about last week, where it's just about the workers kind of guiding the work themselves, when you actually try to create a more systems level innovation, it becomes much more difficult to adopt these types of innovations. And so what's going on here? I began to try to understand a little bit, and this is the paper that you'll read this week is my paper. I began to try to understand and think about what's exactly going on here. And I saw one example from computer science. This is known as Conway's law. And it states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So in other words, however your project or your company is organized, whatever it is that you design will kind of copy the communication that exists within your company or within your project, which is done by multiple companies. And this has been known as the mirroring theory. So the product will mirror the organization. I won't get too much into depth of that, but you'll read more about it in the paper, is the idea that a product and an organization will mirror each other in terms of their structures. And then I always like to ask the question, you know, in the construction industry, do our final products demonstrate a thriving communication and organizational structure? And I showed this example earlier, where we see that not always do we have a very good communication and organizational structure, and as a result, our final products often suffer. Suffer in terms of coordination, in terms of productivity, many different things. So if you could describe kind of how things are organized at a kind of stakeholder level, we have what's known as a decentralized organization. Projects are very decentralized. They occur for a short period of time. And you have many different low bid firms through the tendering process that kind of coordinate loosely with each other. And then you'll have a systems integrator, that's the circle in green. And that's during the design stage, often the architect, and during the construction phase, it's often the tier 1 general contractor. But they're not a very strong coordinator. It's very different than in, say, the car manufacturing industry, where you have a strong lead coordinator like Toyota or BMW that sets the rules of the game. In this case, the system integrators in construction is very weak, and they just kind of try to make everything work together, but they don't have a lot of control over the other parties. And this is how construction has been organized for several decades now. But we're starting to see there's some problems to this approach. In particular, this is one way to think about the problems that occur when you have a certain industry structure. And I'll read these 2 statements. Over time, organizations develop organizational structures and information channels that are focused on component level activities. But these organizations tend to lose their ability to innovate at the global level. All right, so I'll read that again really quickly. Over time, organizations develop organizational structures and information channels that are focused on component level activities. So component level activities would be, you know, the structural system or the mechanical system, or very kind of smaller level activities, but not the overall system. And these organizations tend to lose their ability to innovate at the global level. And this has been theorized as a mirroring trap. So in other words, what happens is that in our industry, in architecture, engineering, and construction, the knowledge that we have is so siloed and so fragmented that we've really lost the ability to reimagine the entire system from the ground up. And we tend to just operate within these little silos where our tasks mirror the knowledge that we have. If I would say that another way, it would be that a structural engineer only knows about structural engineering and knows very little about architecture. And an architect might only know about design, but knows very little about construction management. And a supplier might know a lot about, you know, mechanical piping, but doesn't know anything about the needs of the insulation or the concrete or something like this. So we have this mirroring trap where everyone just knows their little piece of the puzzle, but no one is able to reimagine the entire system. And the goal, I think, of industrialized construction and some of the new movements that's been coming out has been to break out of that trap and to get away from that kind of simplistic thinking of everyone has like a little role, but we can't reimagine the system. And I'm going to show you kind of 4 different ways that I've seen in the industry that we're trying to get out of the trap and trying to find new ways to collaborate and integrate with each other. So here on the left, we have our kind of what I would call the way we're organized today, the traditional way with this decentralized organization. And then on the top, we have kind of a span of fragmentation to integration, right? So as you go from left to right, you have more integrated solutions. Now, integrated is not necessarily bad, but what happens is that there are different strengths and advantages to fragmentation and to integration. And we'll talk about those in a moment. Okay, just doing a quick mic check, making sure everything's good, making sure everyone's following along. If I could get a couple people in the chat, maybe to just say, you know, everything's coming through clear. All right, great. Good, and I see that Param has said that the PDF of the slides are now online, so you can also pull them up online if you want to follow along on the PDF. Great, all right, thanks everyone for the positive feedback. It's kind of weird to speak into the camera and not know if anybody's following along. And more difficult than when in class. Okay, so let's keep going. So what I'm going to describe are 4 different ways that I see this fragmentation to integration process unfolding right now in construction through oftentimes new startups, but not always new startups. And so you can start to think about that also as you think about how you might approach your new company that you'll propose for the group project. So the first one is supply chain integration practices. And I think this is a lot of what's happening today. For those of you that took my Lean Integrated Digital Project Delivery class, I think this is really what's occurring today through tools like BIM and Lean, where people are coming together, they're using new forms of planning, new forms of collaboration. And in the end, what this does is allows you to integrate information, integrate organization, and integrate processes. It doesn't really change the structure of our industry at all. So what I say is that you have these new integration practices. There are ways that the supply chain can be a little bit more integrated. You bring all the bubbles a little bit closer together so people collaborate a little bit more. But overall, the structure doesn't change very much. And so we're not going to speak too much about that in this class. That's actually my autumn semester class. We talk about those tools, and they're very helpful tools for managing projects, but they're not necessarily restructuring and changing the industry. The next is also what I talk about in class. So what's going to happen tomorrow? I guess this is my question. What will be the future of this kind of next steps towards integration? We also talked in my class about this project-based company or integrated project delivery that has a new kind of project-based firm and signs a single multi-party contract where everyone shares risk and shares rewards. So they have a single financial destiny. And that's another example where I feel like we're now moving towards more integration at the project level. And again, that's not the scope of this class, but just an example of how I see things becoming more integrated. Now, these first 3 approaches are all characterized by still a project orientation. If you think back to the original set of slides, and we talked about the longitudinal fragmentation where projects kind of start and end and the teams break apart. These projects all still have that same problem where you do a project, the project ends, and all the knowledge tends to get lost. So what we're really seeing, and what I really want to talk about a lot today, is this new platform orientation. We're seeing this new rise in platforms, and we'll have future lectures about platforms, but that have a platform orientation. And here's my very simple 1-slide summary of what a platform is for industrialized construction. We'll talk about this more, as I said. But in a normal process for industrialized process, you might think from left to right, you have design and customer acquisition, you have some kind of engineering, some manufacturing, production, and then assembly and logistics. We're very used to this process flowing downstream. So each stakeholder kind of passes the information from design to configuration engineering to manufacturing. And this is very normal for the industry. The difference is that when you have a platform organization, you also create a method. It can be a digital platform or a physical platform or some kind of combination of the two where you have specific rules and restraints about how the system should work. And those rules and restraints get transferred upstream into the earlier phases of the planning. So in other words, you've taken the rules about how assembly and logistics should happen on the construction site, and you move those to the manufacturing and production stage. And then you take those and you move those to the configuration stage, and you move those all the way into the design stage, so that you're not designing something that doesn't match your downstream activities. So you're not designing a building that then you give it to the manufacturers and they say, look, we can't build this. And then you have to go through this whole rework process and redoing. A platform is meant to be a specific way that you embed rules and restraints, you transfer them upstream, and in that way you're able to improve the platform. And then you keep iterating and making the platform better and better from project to project. So all your knowledge gets embedded into the platform. Let me just kind of show you kind of an overall platform orientations, and then we'll have some more examples of these platforms in our case studies. So the first platform orientation, I move all the way over to the farthest level of integration, is one of vertical integration. So vertical integration means essentially that multiple activities are combined into the same company. So this would mean that you would have a real estate development company combined with an architecture and engineering company, combined with a construction company, combined with a manufacturer, and maybe even combined with operations and management. And you would put all of those different, in a traditional processes are all separate, different fragmented firms. You put them all in the same company. And the idea is that you can then link the processes, link the information much more easily than if they're different fragmented companies that are separate from one another. So on the, a couple of examples of this, later in this lecture after the break, I'll speak about Katerra as the very up and coming example here. There's also Beauclerc, which is the joint venture of Skanska and IKEA I've mentioned a few times in class. We'll also have a guest lecture from them. And Goldbeck in Germany is also a vertically integrated company. And the way that a vertically integrated company is structured is that they will have a central firm, and then they'll have departments. But everything you can see here is in green because it's all contained within the same company. And this allows you to really iterate within your own company and not be reliant upon outsiders. This enables you to go very fast. But there is a bit of a downside to this, is that it costs a lot of money to be vertically integrated. Fragmentation enables you to be more agile and spread yourself among many different projects. But a vertically integrated company carries much more risk for costs. So it's not to say that this kind of integration is necessarily better, but we're certainly seeing that this is one major trend right now in the industry. All right, next we have the final category, which is what I call Industry 4.0 integration, or I also refer to it as digital systems integration. And maybe it helps a little bit if I discuss the principles of Industry 4.0. You've probably heard the term by now. A lot of people are talking about it. I think not so many people know what it means. But this would be a very basic overview of Industry 4.0 as it might apply in industrialized construction. First, the product developer, so the central firm, is going to be a capital light digital systems integrator. So they're not trying to own a manufacturing line or even be vertically integrated, but to be able to, oh, I see Alina has a question about a feedback loop. We'll get to that in a second. Good question. They're not trying to own the entire life cycle vertically, but they will try to integrate different parts through digital technologies. They'll work iteratively with clients to understand use cases, so they're really trying to focus in on specific market segments. They will modularize, and modularize does not mean modular construction, but they'll try to create a modular product design, which means that there are very standard interfaces that can be swapped out the same way that a computer is put together today, that you can have different parts that are swapped out. You modularize the product architecture so you can outsource the modules to other fabricators and suppliers. And then you build and use digital product models throughout the life cycle. Of course, we want to have digital product models. and then you co-create the module designs with supply chain partners. So we'll talk specifically with one example from Project Frog in the case study example about how they're able to do this. And that might give some more explanation on the Industry 4.0. But those are some of the high-level principles about Industry 4.0. And so what that looks like is that you'll have kind of a central company that's the integrator. They're kind of the one that owns the platform. If you think about it with other examples, this might be, you might think about it like Apple or with their App Store, or maybe something like Airbnb with they kind of run the rules of the game from the platform, but they don't actually own any of the supply. Instead, they have long-term partners in different ways. And those are kind of the ones that are on the outside. The periphery are these long-term partners in the supply chain. And then you would not try to tender each project, but you would go to your preferred partners and you would construct your project together, and they would provide you with the manufacturing. Yeah, so let's see if this is the end. Yep, exactly. So we have about 15 minutes until the break, quite a while. So maybe if people have a few questions, we can jump into those questions. I see that Alina had a question about a feedback loop. And yeah, okay, so 2 questions. So Alina asks about a feedback loop, and could it be that all firms create their own platforms which might not be compatible in the end? I'll answer the first question about the feedback loop. Yes, absolutely. The idea is to create a feedback loop. The way to think about it is about how product development happens today in, for example, with mobile phones and the iPhone, I think is the best example. So you have iPhone version 1 and then 2, and then now we're on iPhone version, I think 12 or something. I can't keep track of which version is which anymore. But each loop is an improvement on the previous design, and you keep the existing products, you keep the existing framework that works, and you kind of iteratively improve other parts. This is very different than how we treat buildings today, which is that every building is a prototype. We often start from scratch. But having a very specific product platform enables us to kind of take lessons from project A and feed it back into the next version, the version 2, the version 3, the version 4 of the product platform. And we'll talk about how that works in a future lecture when we talk about product platforms in construction. The second question is, could it be that all firms create their own platforms which might not be compatible in the end? And the answer is yes. This is going to be a problem. There are different people have different views on this. So typically these Industry 4.0 digital systems integrators, they want to create open source platforms because they want to be at the center and they want everyone to kind of play on their platform. And then at the same time, vertically integrated companies are creating their own internal platforms. Katerra, for example, has their own proprietary platform that nobody else necessarily has access to, although they're changing that a little bit. But others have their own specific platforms. And then these platforms might not be compatible. And this could be a problem in the long run, of course. But we're so early in this that I'm not sure that we've seen it be a problem yet. But I would expect that there might be some consolidation, or there might be different ways that we create kind of more a platform ecosystem where there are a few open source platforms which all the different companies can participate in. That's a very good question though, Lena. Does anybody else have any questions? I'll just wait another 30 seconds in case someone is typing. Good, okay. So then I haven't seen any more questions. I think, as I promised, we're going to be a bit shorter today. So why don't we go ahead and take our break now. We'll take it for about 10 or 15 minutes. If you do have any more questions, you can ask them in the group chat. Let's say 10 minutes then. So I'll say that let's come back together at 3:25, and then we will have the second half of the presentation, which will be 3 case studies. I'll try to be more specific about how 3 different strategies are emerging with very specific examples from Silicon Valley. So we'll take a break and we'll come back together at 3:25. All right, so we'll come back from the break now. If I ever have any issues with audio or anything like that, again, just put a note in the comments. But I wanted to just start by answering a few questions, a few very good questions that people had. First, Anton had the question about recording the video lecture, so let me just say it again to make sure it's clear. We will do our best to record all lectures moving forward, although I expect next week we will be back in the lecture hall as normal. But the advantage of recording is that if you do feel unwell, you can know that you can stay home and watch the recording later and not feel like you have to come to class to get the material. So we want to make sure that everyone's able to do that. We will update you with more information about that. I need to find out from ETH, what's required to do that. So I don't promise it for every class, but we're looking into seeing how we can do that. Timo had a really great question about vertical integration, promoting the development of massive firms, leading to an industry with only a few bigger firms on top, similar to the tech industry. I would say it's a great segue to the next part, because we're going to talk specifically about one company that's trying to do that, Katerra. They're trying to be like the tech industry and be this new massive firm that wipes everybody else out. And I particularly am a bit worried about that. I also don't know if it's the best strategy for construction. I'll say a little bit more about that. But this very much could be a way that things are going with the momentum that we're seeing right now. We could see, a lot of larger vertically integrated firms. Now, the reason why they might wipe out the other smaller companies is because these smaller companies are not adopting digital tools and digital fabrication processes to the degree that they could. So by them being slow, they're creating the opportunity for very large tech-like companies to come in. So I don't want to say, these smaller companies, are blameless. They're actually being very slow about their adoption of these technologies. So in some ways, they've left themselves open to disruption. But I don't want to see a future where everything is kind of a couple companies all vertically integrated. And I don't think we'll go that way. But we are actually doing some work on how we can have more interconnected, open source, open systems at our chair. We think that will be really important in the future. The second question from Irfan is that, is it correct that with new, more integrated organizational structures, industrial manufacturing in the factory must necessarily be used, thus replacing the traditional craft on site? Yes and no. So I think it's done because people want to connect the design to production chain. So that's why we're seeing this integrated organizational structure. We'll also talk about that in a moment with digital building components. Is that it's very difficult to take a traditional BIM workflow today and connect it directly to manufacturing. There's some incompatibilities that happen there. So companies are building new design to production digital chains from scratch because they want to take advantage of industrial manufacturing in the factory. Now, there are also some examples of vertically integrated companies with very low levels of automation. Bokluk would be one of them. I mean, you'll see their guest lecture in a couple weeks. They definitely have some advanced manufacturing, but really actually they just make a very nice factory line in a factory, but with humans doing the craft work in more ergonomical positions. So they don't have to bend down and have such difficult positions. It's actually just making it better for the workers, making the workers more productive. But it is done more in a factory setting. So I would say that you're correct. This is the motivation for doing it, is this kind of industrial manufacturing and replacing the traditional craft on site. Because traditional craft on site, as we saw last week, is suffering from lack of availability. We don't have enough laborers that can meet the needs that we have for construction. And it's very expensive because we don't have those laborers. So it's a good question. And I think you'll see with some additional guest lectures that there are very different approaches to this industrial manufacturing, some highly robotic, some not. Yeah, we can we can say more as we keep going. All right, so if there's no more questions, great, yeah, you're welcome, Irfan. If there's no more questions, we're gonna jump into part 2, and I think we'll be done by about 4 o'clock. Maybe have some time for some questions till about 4:10, and you'll get out about 20 minutes early. So there's a nice benefit to doing it online, is that you don't have to come to the class, and you get to get out a little bit early. So hopefully it's not too inconvenient for you that we're doing it like this week. So we're going to talk about disruption from Silicon Valley. So last week we saw an example from Japan, and my goal in this class is to give you lots of examples of how these companies are happening across the world. And so here we have 3 case studies that are right now happening in Silicon Valley. I studied these when I was at Stanford, and I just wanted to present them to you as different approaches. They don't take the same approach at all. And they actually start from different starting points. They're not all coming from the same place, but all 3 of them are doing what they're doing because they're trying to embrace industrialized construction. So the bigger point is that they're looking at using industrialized construction, but then they have different ways to achieve that goal. And so let me first start, and I don't know if the chat is blocking or not. So let me see if I can just move this. This was a very short white paper we did, and you can see it if you can download the white paper off of the slides when the slide deck is shared. Great, thanks, Alina. That investor funding in industrialized construction seems to be going through the roof. So I first started working on industrialized construction about 2013, first started studying and started organizing some events at Stanford in 2015. And we just thought, okay, there seems to be a lot of funding coming in, and we had no idea that the amount was going to keep increasing. So in 2018, we had over $1 billion in North America given to industrialized construction startups. Overall, in all of the construction industry, there was about $3 billion of investment. A lot of that went into construction tech, so you can think things like BIM and drones and things like that. But over $1 billion went specifically into new construction companies that were developing new products, new platforms, and were kind of vertically integrated or digital systems integrated. So there's been a major investment, and I would say if I had 2019 numbers, it would probably be very high again, because we continue to see a lot of investment in this area. I will say also, I know from conversations that I can't share, I can't share specific details. This is not just the US. I know in Germany, there's going to be an announcement relatively soon that a German company using the same model is going to announce a major round of funding. So it's something that you shouldn't think is just happening in North America. It's actually happening around the world right now. The UK has a lot going on. And so there's some pretty significant things happening. I like to say it's kind of an unprecedented time in construction industry. And so I don't want to be too dramatic about it, but it's quite amazing to see how much change is happening in Silicon Valley and other places. In addition, I mean, there's a lot of interest from large tech companies, and that can be good or bad, but companies like Amazon, Google, who else? Well, Facebook isn't investing, but they're trying to adopt some industrialized construction. Oh, and also Airbnb. So when I was at Stanford in January, Airbnb told me they have a team of 50 people who have been working for the last 2 years in secrecy on their new industrialized construction idea within Airbnb. So they said they'll announce it in like April or something like this, what they've been working on. So I'm excited to see whatever that is. Again, I mean, it's interesting when you have such interest from large tech companies in construction, and there are some negatives there. So I don't want to make it sound like that's all positive, but the interest is really unprecedented. Okay, so if we talk more about this mirroring challenge and why we're seeing this change, the point that I like to make is that industrialized construction really requires a systems level redesign. So it's not about changing little pieces. That's prefabrication. Just taking an old design and making it off-site is prefabrication. Industrialized construction is a full systems level redesign where you optimize for very different things than you do in the traditional kind of design bid tender process. And so the goal that we're trying to discuss today are, what are these business models and technical approaches that are allowing companies to kind of break the mirror? So again, the mirror is that, you know, that you only know structural engineering, but you don't really rethink the whole building and optimize for the overall good of the system. You just optimize your little piece. But how can we break away from that and really optimize the overall product again? And so there's three specific approaches that I've identified in some of my research, and I think it's a helpful starting point. These are actually three business models that have come from, they also come from that kind of theoretical framework I showed before the break. The first one is that many tier one contractors, general contractors, are investing in a spin-off factory. And so there's a company called Digital Building Components that has been a spin-off of a larger contractor. And this would be like Implenia deciding to invest in their own factory and making their own factory separate from Implenia, but that they would do industrialized construction within. Then there's vertical integration. I'll talk about Katerra and give some more information about them. And then finally, there's the digital systems integration, and I'll show some examples from Project Frog. Okay, so let's jump into number one. So this is the idea of a spin-off factory from a tier one general contractor. If you want to see the full slides, you can actually click on the link and you can see the full set of slides. I'm actually just presenting from a deck that they shared with me for one of our industrialized construction forum. But there was a large general contractor called DPR Construction in Silicon Valley. Think of them very similar to like how Implenia, you might think of Implenia today in Switzerland. And they decided that they wanted to move away from being what they called brokers towards to be more builders. So they wanted to invest in their own prefabrication facilities. And so they actually funded from within their own company a factory. They invested 50% of the cost into this new company called Digital Building Components. And it's a spin-off because it's actually not owned by DPR. They funded it and they own the equity, but they're a totally separate company. And in fact, they have the freedom to sell to competitors of DPR, which is quite interesting to see how that might happen. But here you can kind of see, this is their nice picture here. And they use this example where, how long does it take on the job site to install 45,000 sheathing screws? So this is on the left, you can see the workers putting the screw into place. It's not very ergonomic. He has to reach really high with a very heavy tool. Might not be so good for his long-term health, some safety risks, etc. But they counted, it took 125 hours for a worker to install that many screws on the site, and it took 18 hours in their factory to install the screws. So this was their specific value add of why they wanted to industrialize this process. They have specific digital fabrication products that they create. So they have CFS load-bearing structures. These are the actual structural walls. Then they have the exterior panels, and then they have the tech wall interior panels, which you can see are kind of pre-made and then put into place. And so their goal was to drive directly from a 3D BIM model, efficiency of manufacturing, but they don't want to go towards mass production, right? So again, we talked about the failures of mass production earlier. Nobody really wants mass production as their outcome. So they use a model-driven process. Here you can see, you know, model versus reality, left and right. The BIM on the left, building information model, and then the actual construction on the right. And then here's kind of their overall process. So they might have an architectural design model done in Revit here, and then they're going to move towards a fabrication model. They've learned a lot about how they have to clean up that whole process. And then they're able to export it in different ways to different ones of their different lines in their factory. So they have a wall line welding, they have, they roll their own steel joints, they have sheathing, and then they have many different processes. I don't want to say too much because I'm not the expert here, but this is just from a high level, my understanding. And then on the left, they've started thinking about their company as a service, but more recently they've been productizing. So their walls, they kind of say our wall is a product. We deliver an integrated wall with, for example, the mechanical, structural, electrical, all embedded within the single wall, and that's a product that you can buy from us. And in that way, they're trying to add value into their product. So here was an example where they used unique panelized structures to offer speed, quality, reduced costs. This was a university project in California. They showed how unique it was. So of the panels, there was 73% unique panels, and of the wall panels, there was 40% uniqueness. So they're really trying to still solve kind of this bespoke digital fabrication challenge, but it is a very big challenge when you go from a BIM to a fabrication model. So this is the process in which they do it. So they have a design model, then they move towards the populated model, they merge a subcontractor model, and then they try to have these gates where they freeze the design. So they freeze the design at this point, and then they freeze the coordination, and then they're able to place their order, fabricate, and then construct on site. Let's see, I think there's a few. Yeah, what they found is that a lot of the more effort needs to go into coordination. They spend much more time coordinating the project because they can't afford that there are mistakes in the fabrication level. You just don't have the same level of time to make last minute changes. You really have to coordinate everything ahead of time. And then again, here talking about systems, they're really trying to focus on their system-based decision-making process. And then they want to generate products across multiple building sites. So this is the idea that they create a product, and that product can be used in multiple buildings. And you don't just have a single kind of one-off prototype done over and over again. So the goal that they're moving towards now is to develop a system-based logic to predefine the enclosure system based on a building template, and they want to define the parameters for the modular design solution so they're allowed for site-specific and geography variation. So they're moving towards this idea of mass customization, which we've talked about. But they're doing it very much from a project to project orientation. That's why I would kind of fit them on the left side of a project-based approach. But they want to move towards more platformization and thinking about the building as a product. Here are some of their targets, 30% shorter delivery, reduce costs, and take full advantage of their factory. Yeah, I'm going to skip over these. So these are just kind of their big goals. And here's kind of my summary of this approach. So it's quite good for a large contractor to take this approach because there's little change to their established business. They're actually just kind of still operating project by project, but they've created kind of a partner company that enables them for a structured learning process. So they kind of have a sister company that helps them learn about industrialization, and they can continue to work with them on that approach. At the same time, there are some negatives to this approach. It's actually quite slow to do this. You can't really innovate that quickly. And when you talk to people at both DPR construction and digital building components, they talk about they have to re-educate their supply chain over and over again. They have to keep convincing the same people on every project, hey, here's what we're going to do. Here's how things are different with our process. Here's how much we have to freeze the design model. And this is a challenge for implementation. So it's again, not a technology process sometimes, but educating the supply chain, which takes a lot of time when it's not within the control of your company. Okay, if you have any questions, you can write them down. I probably won't stop, but I'll get to them all at the end, but feel free to write them as I'm going. Okay, so here's an example from Katerra. So again, these are the big company now. I would say that Katerra is getting a lot of headlines, so I'll talk about them, but there are many, many industrialized, vertically integrated companies other than Katerra, but I won't say too much more about them. I'll just talk about Katerra now. They are vertically integrated. They raised, this was in 2018, they raised a new round of 865 million. I think their total is over $1.2 billion in investment from SoftBank is the major leader in their investment. So $1.2 billion, right? That's an insane amount of money. And the whole goal is to become the first global industrialized construction company. That's what they're betting on. They're 5 years old now, so they were founded in 2015. And to give an example of the vertical integration on the right side, you can see these are all the different parts of the company that are within Katerra. So they have architecture, engineering, manufacturing, general contracting, property management, renovation, software. They're developing their own software systems. You know, they're doing all of it themselves in-house. This is actually, I see the question from Takayoshi about how do you explain a sudden increase in 2018? This is your answer, is that Katerra just got a huge amount of money and it kind of skewed the numbers. That's really why we see such a big increase, mostly from Katerra. But it's still continuing now, I think, outside of just Katerra. So these are a few slides from their presentation. So they were talking about their global reach. Like I said, they want to be a global industrialized construction company. They're starting in the US and they have several offices. I think in green or in white, you can see their factories that they plan in the US. I think they plan to have 4 or 5 factories operate in the US by the end of next year. But they're looking to be global. They're operating in the Middle East. They have an engineering center in Graz. They have global ambitions. I think we should say that. Their Tracy factory here is actually done and opened. I forgot to include, I have a picture outside. They didn't let me take any pictures inside, but I got to tour their factory about a month ago. And it was really interesting to see. It's very much a work in process, but it also has more advanced manufacturing equipment and robotics than I've seen anywhere else in any factory I've ever been to. So, you know, there was some good and some bad there. There's a lot to be done, but they're definitely very ambitious in how they're trying to do it. So this is their whole philosophy. It's end-to-end integration with significant investment in design and technical innovation. So they're really looking at these kind of manufactured assemblies, but they're also thinking about their overall set of products, and they want to manufacture all the products themselves. They're trying to invest in factory automation. So here's some of the things that they have in their factory. They have more things than this, but I think they're not talking about them yet, and I'm not allowed to talk about them. But here you can see their large factory in Tracy. It really was like a housing factory. It was everything you need for a house is in this factory, and it will ship everything that you need to build your house. But they're doing everything from making their own cabinets, making their own countertops, drain, waste, vent, plumbing stacks. They want to control everything. And it seems to be a very aggressive strategy, but it seems to be the approach that they think will work for them. I linked the overall presentation so you can see it, but here's a few examples of how they're thinking about what are the key building blocks that they're going to use, and they're using cross-laminated timber as their floor plate. And then they're trying to think about how do we automate the process of putting together these different building blocks for the project. So that's where you can think about what are the subcomponents that need to be used in the product line. And then how can we reassemble them in different ways so that you create this, again, goal of mass customization. And here, again, is what, you know, one vision of what that final office product might look like. There's many, many more slides on the presentation I linked, which is publicly available. I think this is interesting because it shows that they have the ability to rethink new product design. This is their bath kits. It's a very simple idea. It's essentially just packing, like IKEA style, all of the different pieces inside of a little kit. And then when you're done, ship that kit on site and kind of pull it apart and then install it on place. Now, that might not seem like such a crazy idea, but if you think about the number of different people in a traditional process that have to come through a bathroom or a toilet room to assemble it, it's probably like between 10 to 20 different companies will come through and do the tile and do the sheathing and do the toilet and et cetera, et cetera. And they said, why don't we just put it all into one single box? And then let's ship that box onto site, and it's all kind of ready to go, snap into place, and then we'll just put it into place very quickly on site within our own company. And I think that's the example of this mirror breaking, right? They said, let's get away from optimizing each little piece, and let's redesign the whole system of how we design, manufacture, ship, and assemble a bathroom for a project. And then that was their bath kit that they came up with. So I think a very small, simple example, but a good example of this kind of rethinking the systems design using principles like design for manufacturing and assembly. And then the software side. I mean, the story, as I understand it, is Katerra said, we started using Autodesk products and other BIM software, and we decided that it doesn't work for us. There's too much fragmentation. It's too slow. It doesn't enable us to connect our manufacturing systems with our design systems. So we're just going to build our own platform from scratch. And that's how they came up with Katerra Apollo. I don't have too much more data about this. You can go onto YouTube and see their keynotes about Katerra Apollo, although I still feel like there's not a lot of information out there about it. But essentially, it's a new platform. When this is their goal. Again, this is a bit PR promotional, but this is how they describe it. So in red would be traditional processes. And each time you go from planning to the next stage, so from planning to schematic design, there's an information loss when you have a handover, right? You kind of lose some digital data. And they show that at each stage in red, it keeps happening. So you have a huge information loss. And by the end, you kind of are way down here, a lot of information lost. They say, okay, if you have BIM, you kind of turn to the green, you're better, right? So now you have less information loss, but you still have information loss. And then they say they're going to go towards data-driven construction with less loss because it's all one integrated platform. Again, it's a bit PR, but I have seen some of their examples of how they've reduced, for example, the design time of a new building over 3 or 4 iterations down to a couple of hours from several days. So again, it's about generating floor plans that fit within your product system and doing it in a very smart way. Okay, so let me just summarize Katerra then. I think there are some advantages to this vertical integration is that you have what you could say in software, a full stack. So you have product integration all the way from real estate and architecture, all the way through manufacturing and assembly on site and even operations if you want. And that full stack product integration really gives you the opportunity to innovate at the systems level, to create design to production chains. And it enables you to go very fast. So you have a much greater speed and you can capture market share. That's what Katerra is trying to do. Now there's a very negative side to this. I think a highly negative side is that it's quite capital intensive. There's a lot of risk in investing in a factory that builds everything. And we will see what happens if there's an economic downturn. We'll see if Katerra is able to survive such a downturn. So I don't know what will happen if we have such a downturn, but we will see what happens. Irfan has a question: is there information about the approximate financial savings in percent for the end customer with Katerra and others? I don't have data from Katerra, and I also think that they still haven't successfully shown that they can execute this. They're very much scaling up, but I wouldn't say they're super efficient. There's potential. I do know, for example, for the company Bokluk, which is this joint venture, Skanska and IKEA, they're vertically integrated, and you can ask our guest lecturer, about this. But what I've heard is that their price is 20% below similar products on the market. So they are 20% cheaper than their competition, and at the same time they have a 20% product margin. So that means that on every project that they do, that for every, they're making 20%, versus typically in construction, a general contractor makes somewhere between 3 to 5% margins. So now this is a company that's been around for 20 years, Bokluk, so it's not exactly that easy for everyone to get to that point, but they're a very highly profitable, vertically integrated company. So it's shown that it can be done, but it also, like I said, has a lot of risk involved with it. Very good question. All right, our last one is Project Frog, and they're a great example, I think, of digital systems integration. So Project Frog started actually over 10 years ago. They started by making schools, and their original products were actually modules. They just made modular construction for schools, and they kind of thought that they could just do this in this kind of prefab modular approach to schools. They found that actually the schools needed more flexibility, so they started moving away from this modular approach, and they started adopting more of a kit of parts approach. And then they developed something called the Frog Kit. So here you can see very much the idea of a kit of parts. These are these are specifically the kind of different parts that they work with. And Project Frog was an example of a Industry 4.0 because Project Frog does not manufacture any parts themselves. All of these parts are sourced from different suppliers. So they've kind of collaborated with different suppliers, and they said, look, can you deliver us this product? And then Project Frog kind of tested and made sure they all fit together on site, and then developed a Industry 4.0 platform around that. So that was their starting point, where they created this kind of systems integration. But then they went further because they realized that, you know, this is very nice for schools, but this isn't necessarily applicable to all buildings. But instead, what if we start investing in kind of digital systems integration, and we become the software that enables different systems to be configured and customized? And that's where they started moving towards you know, more project automation, and they came up with, this is a couple years old, with their Frog automation engine. And in a couple of weeks, they're going to be giving a guest lecture in the course talking about their new product, which is called Kit Connect. But I'm not going to go into that. I'm more just going to talk about their older approach. And the idea was that you had a product design where you would make several different products. They would go into your parts library, and then you would have this configuration engine that would put the parts together based on the shape grammar, on how the geometry would fit together, and also the rules. And they would hard code those rules into the system. But they would do this in a very lightweight kind of browser-based plugin called My Project Frog. You can actually go there right now. I'll type it into the chat. I think you can just go there right now and even download their configurator and play around with it if you want. But this is what it does. So you go in there, and I showed this video in the first class, and you just put your walls in place. You decide where you want things to go. It's very lightweight. It's on in this case, it was on a 4-foot grid. So there are very strict rules about how it works, but still there's a lot of flexibility. And they made this tool for architects to design their school system, but then they also wanted to make sure the architects were taking consideration of the downstream rules. So I'll just show this video one more time. They wanted to make sure that the architects were not designing something that didn't match their suppliers, right? So they didn't want to promise that they could just change the manufacturing process. They wanted something that matches the rules of their suppliers. They also wanted to make sure they matched the local codes. So they made sure that the codes and the seismic requirements and all of the structural engineering also goes into the system. So you have to place a certain amount of shear walls and things like this. But when it's all done, you just click, you know, I'm done. It checks the status. And then this is what I showed earlier, is that you can generate everything from this kind of configurator. You can generate your bill of materials. You can generate a BIM, and this is, BIM becomes the output of this process, a component model. You have your shop drawings that need to be done, and you also can automate permit and construction. So structural calculations, architecture drawings, structural drawings can all be automated based on this approach. Now this has the benefit that it's very capital light. So Project Frog has really kind of embraced this, and they're now, while they still do implement their own buildings still, they're trying to be more and more kind of the software provider, the digital systems integration, the software side of things, and not just because they find that that's more scalable, not just the building developer. And it's very agile development. They will say, look, we don't have to just be stuck with a steel. We didn't buy a bunch of CNC fabricators for timber or whatever it is, timber, steel. They're not tied to a specific manufacturing investment, so they actually don't have to worry about what kind of digital system they design. They're more agile in their software development and in the final products. There are some downsides to this approach, is that there's less control over the product. You're more reliant upon on your suppliers. So you're not reliant on your own decisions like Katerra. You have to kind of co-create your products with the supply chain. So it takes a little bit longer in order to do that, and there are some challenges there. All right, so to kind of summarize, wrap everything up, here's the, oh, I see a question from Alina. How did they create this automation? Were the engineers working with the software development? Yes, they, because they already had been doing their own modular buildings, they knew how modular construction and prefabrication worked. They also had a software team, and essentially, they were all in the same room, and they just started working together. The architects would tell them, here's how the design works, here's how we want it to look. And the software engineers would start coding the rules. And they had engineers as well. The engineers would say, here's how the pieces have to fit together. Here's how the shear has to be transferred and things like this. And through that process, they were able to kind of come together and come up with the approach. They did it, I think, initially in Revit, but then they hard coded the rules in their own kind of configuration, what they call their Frog automation engine. But that's a good question. You could ask Mike when he gives a guest lecture, how were they successful to do this? He told me, look, we have architects now that think like software engineers and software engineers that think like architects. And it's a perfect example of this mirror breaking, right? So we don't have, the architects on one side and the software people and the BIM people on the other side. It's kind of changing the roles and breaking free of these silos. So a very good question. All right, so to summarize, you have the spin-off factory, you have the vertical integration, and you have the digital systems integration. And here I've summarized the benefits. So there was little change in business, structured learning process, but there was slower implementation for digital building components. Katerra has a lot of full stack integration, which enables them to have speed, but it's very capital intensive, so there's a lot of risk there. And Project Frog is capital light and has agile development, but has much less control over the product and a longer co-creation when compared to someone like Katerra. So I'll end with this slide, which this is it's not a very high resolution, sorry for that, but this is the kind of innovator's dilemma from Clayton Christensen, which talks about how disruptive innovations happen. And I just like to say, is this the beginning of some industry disruption with these different business models and different customer segments? And the idea is that, you have performance on the left and you have time on the right. And so you have, when you think about the ability of general contractors and existing structures to deliver projects today, we can do very complex things. We can do airports and infrastructure and all of these things. And so we can compete at the level of this kind of green line here, right? And we can kind of have these sustaining innovations. I would argue BIM would be, in many ways, one of these sustaining innovations that enable us to do more and more. On the other side, you have this potential for disruptive innovations, and they might actually come from less demanding customers. They might be very simplistic, like mass customization for housing or an office building. They don't seem like they would solve these very complex projects, the needs of these complex projects. But what can happen over time is that if you perfect a new system and you get very good at it, you can actually ramp up the performance much faster to the point where you might even pass the performance of the other types of approaches. Now, I don't think that we're going to replace the kind of project approach for mega projects and infrastructure and things like that. But I do think that a lot of these new approaches are very good for repetitive and mass customized things like housing, hotels, commercial buildings. Many different structures, I think, can be approached using these new business models. And we will see if it does create some kind of industry disruption. I know everyone's very worried about it right now. Everyone's talking about Katerra and saying, we have to look out. But Katerra is not the only one. There are many new companies in this space. So I think that's enough for a webinar. I think it's a lot of time. So I appreciate all of you for your for hanging in there. I'm happy to stick around as many questions as you have. I think the only points that I'll say before I start answering questions is, first of all, assignment number 2 should be out now. It's based on the paper that is loosely based on the first part of this lecture. You have 2 questions to answer for assignment 2, and you have 1 week to submit assignment 2, and then we'll start the peer review process. And then otherwise, I've sent an email out with an update about the class trip on March 20th, and we'll send out an RSVP for that also pretty soon. But please plan on coming. We'll have transportation for you to come by bus. We'll go to the Erne factory it's in Stein-Sachigen, if I say that right. Forgive me, Swiss people, for my terrible pronunciation. And we'll have a tour from 10 to 12. Then we'll have a barbecue, and then we'll be back by 2 p.m. Back to the Hungerberg campus. So we'll have an RSVP soon. And then otherwise, next week, we will talk about opportunities for industrialized construction, and we will follow with a guest lecture from News Story. So with that, I'm happy to take some more questions. Please feel free to type those out. But then I expect that at the same time, people might be dropping off if they don't have questions. So thank you very much, and hopefully we'll see you in person next week. So what are your questions? Please feel free to write them in.